This is part 2 of the Pythagorean theorem 1, starting from 1 minute 44 seconds onwards. Hello everyone, uh, please cut that. To start with, I have just created a right angle triangle, as you can see on the screen, because Pythagorean theorem specifically talks about a right angle triangles. So we will take that with sides A, B and C, where C is hypotenuse, and it says that if you add two of the sides A and B, like base and height of the right angle triangle, if you add squares of those together, it will be equal to the square of the hypotenuse itself. Now let's for a second imagine that we don't know this formula, and since we're talking about a triangle, just know that from now on we will be talking about everything, because triangle comes under geometry. So we will be let's think from that point of view. I just wanted to ask, when we say a square, in terms of geometric formulas, where exactly square comes? Let's say if you have a square or a rectangle, with you, and if I say that side of that square is A, then what does A square signify in that square? It basically means that I'm talking about the area that that particular square covers. So let's take it from there and let's try to see that I have just created two squares using A and B. As you can see, this pink is for A and B, and I'll just try to stitch it there to prove that they actually have a side length of A. So I'll just snap it there and there. As you can see, the area for the square with side length of B is B square, and the area of square with the side length of A is A square. I have to prove that the area for C with the square with side length of C, that is C square, is equal to this A square and B square. So let me just grab one more square here. I've already created it for us so that we can speed up the process. So that, and basically the proof that we are looking for is when I add up the areas of this square and this square, it should be equal to the area of this particular square. How can we prove that? For that, we need to think outside the box. Now, as you can see, when I selected this C square, or this square with side length of C, as you can see that there is one outer mesh around it, and I think that's really interesting, so I want to try and create it. So I actually have one in place for now for us, so I'm just going to go ahead and grab that for us. Just trying to select everything so that it fits around. And I want to put it around in such a way that this is a really interesting shape. Now, what is so interesting about it is that these empty gaps that you can see here, I have that which are like 4 right angle triangles, and I wonder, these empty gaps 1, 2, 3 and 4, and I wonder if I can fit my right angle triangle in this. So I'll just grab, maybe I'll make a copy of this particular triangle, which is same as my right angle triangle with the sides ABC, and I will see, just to make sure if it's the same triangle that we're talking about. Maybe I'll try to fit in here, and as you can see, this works perfectly, and what a coincidence. Now, why don't we just fill this gap with different copies of this right angle triangle and see what happens. So I'm just going to rotate it and flip it into a gap. Grab it down, rotate it, and it snaps. Maybe just flip it around and put it here. Wow, what an interesting idea. I have that. Now what? Now, for a second, let's just remove this right angle triangle on the side. Maybe I don't need this, or maybe I can. Don't need this text. I can select it. Perfect. And let's grab this outline and let's make a copy of it. And let's see what we can do with this. So, just like I tried to fit C square inside a bigger square, I'm going to try and see if I can fit A square and B square inside the bigger square, but the condition is that I need to have these 4 triangles there. So I'm just going to go and grab the 4 triangles. There you go. It's not hard. And yeah, it should work. And somehow I'll have to put them inside. So I'll just put them something like this. Yeah, exactly the way it was. And then I'll try to put my A square and B square. And as you can see, it doesn't really fit together. So I'll have to move my triangles around to make sure, or to find a way where I can fit these 2 squares in place. So one way would be to take this one here and take this one here. And actually that works because, as you can see, I can fit my smaller square here. I created basically 2 rectangles, and that gave me enough space for my 2 squares. And when I did this rearrangement, as you can see, the empty area which was created inside the bigger square was perfectly filled by our smaller squares, which are with the area A square and B square, which in turn proves that when we add up these 2 areas for the inside a bigger square, they actually fill the area which is occupied by the square with the side length of C. So which is that in a way we have proved that A square, that means this is A square, and B square, this is B square, these 2 areas together occupy the same amount of area which this particular bigger square occupies on the right hand side with the side length of C. And hence we can say that Pythagorean theorem stands true for the right angle triangle. I hope this makes your visual understanding a bit clear, and I'll see you again with the next video in which we'll try to prove Pythagorean theorem using some other method. Till then, happy exploring.